Just in 2 minutes, we'll start.
Okay,
Meanwhile, our students are joining.
sure.
What is the batch code, sir? 2504, huh?
Yes, sir. 2504.
2504, 7 p.m. ಅದೇ ಅಲ್ಲ?
Yes, sir.
Yeah. Yes, in the first session we discussed on big data intro. Second is part of part 2, how fault tolerance is working out, correct? Yeah. Spark, sir. So up to now, like we discussed, like the background before the Spark, what was there into the big data industry. Okay, mainly the big data revolution started with Hadoop. Parallelism started with the Teradata, but Teradata has a limitation and not powerful execution model in the Teradata. So first time Hadoop came into the picture with the two features called HDFS and MapReduce. So MapReduce outdated. Nowadays, no one is using. So later, Thales came into the picture. This is also outdated. Think that this is having 1000 GB for easy calculation, approximately 1 terabyte. Within this, some 30% generally as virtual storage. Yes. Pardon? Yeah, you are able to see my screen? Yeah. So generally in every hard disk, at the time of setting up the operating system, we dedicate some virtual storage space. The remaining thing is called as a real storage. That means this is physical storage. Think that 70% for real storage and 30% for virtual storage. So what is 70% among this 1000 GB? 700 GB. Remaining 300 GB. Okay. For example, you want to process something. Let's program 1. Input data is 500 GB. I have 500 GB data here. So when I run this program, if the input is 500 GB, what is the processing style? That thing we need to understand. Okay. So here, Still, I am talking about this disk-based computing one. A program execution. Applied on 500 GB data. So what is the processing style is 300 GB. First stored into virtual storage. From here to here. Let's say this is 300 GB because 500 GB cannot be fit. Suppose processor is 8-bit processor, easy example, or else the 64-bit processor. 64-bit means how many bytes? 8 bytes. Now from here to here, 8 bytes worth data is free, at least. From here to here, 8 bytes is passed. The processed result is sent back to here. Again, that is sent back to virtual storage. Then next, second 8 bytes will be released. Again, that is passed to this one. Processor. In this way, 8 byte, 8 byte, 8 byte, on that way the data cycling is happening. Here, after the cycling, disk to real storage to virtual storage to RAM, RAM to processor. Again, processor data that will be again sent back to RAM, again RAM to virtual storage. Again, next level of 8 bytes will be released. So there are many cycles here. Okay, 300 GB is stored. After that, second step, 8 bytes sent to RAM. Again, third step, save 8 bytes sent to processor. Again, processor data. Sent back to RAM. Again, RAM to virtual storage. Then VS2, next 8 bytes will be released. Released to RAM. In this way, many cycles are there. This is a disk computing style. Got it. Okay, if it is in memory, what is the style? Just observe. Observe the same. Treat this box as a CPU. As usual, here you have a disk. Same as previous pick, I am keeping the 3 components. Is a HD with capacity 1000 GB. 30% VS, virtual storage. Real storage 70%. So for now, I'm taking small data. Let's say here, I have a RAM. A big RAM I'm taking, which is 256 GB RAM. Now 500 GB. Okay, first initially, I'm going with 500 GB. Now here to here, how much? 300 GB.
300 GB.
Here to here, let's say 250 GB is
250.
released. Some 6 GB is occupied by some other services. Okay, 250 GB is the available space. 250 GB will be released. Now cycling between RAM and processor only. Once this 256 GB data completed, then remaining part will be released from the virtual storage. Okay. So this is step number 1. Step number 2. Remaining maybe 250 GB. This is 1, this is 2. Once the first part of data is completed. Now here cycling is between
RAM and processor.
yes, RAM and processor. This approach is faster than regular disk-based computing. That to industry feedback 100 times faster.
Regular disk-based computing.
Yes. So first time, this in-memory computing was introduced by SAP HANA. Introduced by SAP HANA. Okay, but problem with this is not distributed. To support the parallelism, what we need?
DX.
We need it distributed computing. That means the system should support parallelism. So next, Spark and Flunk. Introduced in-memory computing. With the parallel process. What is the problem with non-parallel process? Just if you look into this picture, you can understand. Total how much volume I have in data? 500 GB.
500 GB.
My RAM capacity?
256 GB.
256. Can I load this 500 GB into the RAM at a time?
No.
No. That's why
We
what
are
it has to do,
dividing.
first 250, after completion,
Yes.
next 250, right? It has to wait for one shot, right?
So we are dividing our data.
Now, just think that in a parallel way. If it is parallel way, in what way this in-memory computing works, we'll see. Think that this is Hadoop cluster. On top of Hadoop cluster, I have Spark. One master for Hadoop master, which is name node. Think that is a Spark master. And here I have slave nodes. Let's talk on file one. Suppose every system is having RAM. Think that the upper box is RAM. That to each RAM is 200 GB. For easy calculation, I am taking 200 GB RAM. This is RAM, this is disk. Suppose you have a file with 500 GB. This time a bigger file I am taking, which is 1000 GB. This is the data volume. I am loading it to Hadoop cluster. Request goes to Hadoop master. What is the work of the master, Hadoop master? What is the first work? What Hadoop has to do?
Divides.
Divide the file into blocks. What is the block
Yeah,
size?
blocks.
256.
256. If the block size is 256, how many blocks?
N into block.
4 blocks.
4 blocks.
So that block 1 here, block 2 here, block 3, block 4. What is the volume?
56.
256.
Here. Here it is. Total 750. Up to now, how much volume? 750 plus 18, right? 768 consumed. How much is pending? 1000 GB minus 716.
232.
32.
232.
212, right?
Yes, sir.
The block 4 data occupancy is 212 GB. Now, if you run the process, what Spark is doing? This entire block 1 is loaded into RAM 1. This entire block 2 is stored in RAM 2. This is stored in RAM 3. This is stored in RAM 4. Now, all these blocks will be executed parallelly or sequentially.
Parallel.
Parallel.
Parallelly by Spark in memory computing style. All of you understood?
Yes,
So
sir.
here, the speed, the reason for speed, one is parallelism. Second one, at each node, in-memory computing. Understand? Suppose if my data volume is 1500 GB, any problem for you?
No, sir.
Because that will be distributed into other different nodes, right?
Yes, sir.
Okay. Let's treat it as case number one. One more case I will show you. This is treated as case one. Case one with Spark. So this kind of things are not possible in SAP HANA. Because first time, why I'm comparing with SAP HANA is the first time in-memory computing was launched with the SAP HANA into the market. 1 minute, sir. Congratulations.
Thank you.
Oh, nice.
I'm expert in
Very good.
this.
We need it. Huh? Later we'll stay. Stay here, I will talk. Thank you. Sorry. Okay. Now I'm bringing you to the case two. With less memory capacity, here sufficient RAM is there because we have 256 GB, but 256 GB, okay, let's make it as 300 GB for easy understanding. Then only there is a meaning of case one. 300 GB. Within the 300 GB, 256 can be fitted, right?
Yes, sir.
Think that each one is 300 GB. Each RAM is 300 GB. Because the RAM capacity is 300 GB, that's why 256 block can be stored into the RAM. Understand? Okay. I'm taking a different case where less RAM capacity when compared with the block. Case 2. Less RAM. When compared with the block size. Again, this is Hadoop cluster. As usually have one master. Another master for Spark. It's Hadoop master. It's Spark master. Of course, once you come into the Azure data engineering, you don't talk about this Hadoop. Because we have Databricks cluster. Instead of using Hadoop cluster, we can use Databricks cluster. Think that in this way, many nodes, hundreds of nodes that we have. Here RAM is 50 GB. This is RAM. That's a easy computation. I have 50 GB or 100 GB. Now F1 size is 600 GB. File size is 600 GB. If I move this into Hadoop, what will happen? How many blocks? How many blocks?
3 blocks.
Yes, 3 blocks.
Mhm.
Block 1 size
200.
256.
Block 2 size occupancy
256.
256. Block 3
256.
8.
512.
88.
That means
88.
88.
88.
Block size, okay, 256 will be allocated, but once data is fit into that, remaining space will be released. That's why occupancy is only 88 GB only. So block 1 here, block 2 here, think that block 3 here. Each block is 256, but here how much is fit?
100. And size is 100 GB.
100 GB. Okay. Actually, what happens is, at the time of creating RDDs, we can divide the blocks into the partitions. I can control the number of partitions. Here 250 block 1 data is 256, but here my RAM capacity is 100 GB. That is not directly possible. That's why what is the solution here in Spark is, even though if you have less RAM
Okay.
capacity when compared with block, you can control number of partitions. Let's make the number of partitions as 10 partitions. Okay. Total previous volume, how much? Previous data volume, how much here? Total data volume.
600.
600.
600 GB, right? 600 GB divided by 10 partitions. How much? What is the each partition size?
60.
60 GB. Now, can that 60 GB can be fitted into this RAM?
Yes.
Yes.
Yes. So that means here, total all these blocks. Suppose this is Spark definition. In Spark, data objects are called RDDs. At the time of creating RDD, you can set how many partitions you want. I set 10 partitions. Total file data will be divided into 10 partitions.
And
Now partition 1, partition 2, partition 3, partition 4, partition 5, partition 6, 7, 8, 9. On that way, data will be moved into other nodes. So actually, physical data is available in 3 nodes only. Okay. Now total data distributed across 10 nodes. That too in the RAMs. Now all these 10 nodes, all 10 partitions. Distributed into 10 nodes.
10 minutes.
So that number of parallel process, 10.
10.
So all the 10 tasks are running parallel. That will be memory computing step. Okay. So system 1 is processing system 1 local data. That is called localized processing. But system 1 data, some part of data is distributed into some other nodes. Got it? Again, block 2 data is distributed into other different nodes. Block 3 data is distributed into some other different nodes based on this calculation. Number of partitions 10 means total volume divided by the 10. On that way, the partition distributions will happen. Got it? So when compared with the block size, even though data volume is small, it doesn't matter for, because you are running this in a biggest cluster, Spark cluster. So this kind of feature is not available with SAP HANA. Okay, that's why for mid-range of data volumes, SAP HANA being used, but not for very big volumes of data, for data processing. So even though block RAM size is less, not a problem in Spark cluster. Okay. Then we discuss one more thing. Second feature. What is the second feature of the Spark? MPP.
Master process.
That means now we see
And MPP.
parallel process. That means normal parallel process versus massive parallel process. To make you understanding, I'm using some code here. Forget about that code. Try to understand the process. Suppose input file is sales. Sales.txt. Size is 512 GB. Block size 256 GB. Not 256 GB, sir. We are talking in GBs. That is, GB is a wrong word. 256 MB. So in the previous notes also try to modify this. In Hadoop, the block size is 256 MB, not GBs. Come on, this is a Hadoop and Spark cluster. That means Spark is running on top of Hadoop. In this way, I have 100 nodes. Node 1, 2, 3, 100. I have 100 nodes. Left is Hadoop cluster, Hadoop master. Second thing is Spark master. Later I put the names for the masters, there are different names. Later we discuss about it. As for the case one, that means parallel process. So here also the file size is, let's say, 512 MB. The file size is 512 MB. How many blocks? If the block size is 256 MB.
2.
Blocks. 2 blocks.
Block 1. Block 2. This is the RAM. Think that I have sufficient RAM. Generally, even our normal laptops also are having 16 GB RAMs. Even small machines also are having 16 GB RAMs. Can I fit this 256 block size into the 16 GB RAM? If my block size is 256 MB, can I fit this into 16 GB RAM? Yes. Yes. In case one, I mean to left side picture, how many parallel process now? How many parallel process here?
2.
2 parallel process, right? But in my cluster, how many nodes?
100.
100 nodes. But in this moment, remaining nodes are ideal or not? Even though if I have 100 node cluster, but actual work is done by only 2 nodes in this moment, right? Remaining team members, I mean to say, remaining nodes are in ideal state. Got it. They are not helping this process. Remaining 98 nodes. Okay, observe the massive parallel process. Same, Hadoop and Spark. Remaining things, the workers I am taking. In this way, I have 100. So here my statement, sc.parallelize of, or else sc.text file. My data is equal to sc Spark context. What is that Spark context? In the technical discussion we will do. To read data from a text file is the function. And I am giving some path. Let's say under data, the file is sales.txt. Okay. So this is the statement I applied, and then I am doing some process related statements. Finally, my process will be done by two systems parallelly. Number of parallel process is 2. Okay. Now same thing here. Block 1 stored here, block 2 stored here. But my statement is like this. Data is equal to sc.text file. And I am giving my path, file path, data sales.txt. Up to now there is no change, but I am saying 10. What is the meaning of it? What is the meaning of it? Total data is divided into
10
10 what?
nodes,
Partitions.
10 what?
partitions.
Partitions. Now P1, P2, P3. That too in the RAM. P4, P5. In this way, P10. Now number of parallel process here. How many?
10.
10
10.
Which is speeder, left side or right side?
right
Right.
side.
Right side obviously fast.
Yes.
Got it. So here physical data in normal parallel process, physical data available in 2 machines. That's why max number of parallel process 2
2.
only. But in the case of MPP, physical data available in 2
10
machines.
nodes.
But number of parallel process more than 2, right?
Yes.
Yes, sir.
I can
10.
control it. I can control it. I can control number of partitions at the time of processing. All of you clear?
Sir, here
Yes,
we
sir.
are using only 2 blocks or other blocks also.
No, 2
No.
blocks only.
2 blocks.
2
My
blocks with
file has only
partitions.
2 blocks.
Hmm.
What is the file size? What is the file size?
512 MB.
512 MB.
Block
512
size?
MB.
Block size?
256 MB.
256
Now,
MB.
then how many blocks in my file?
2 blocks.
In the first
2
case,
blocks.
2 blocks. Second case also 2 blocks.
Hmm.
But during process, I am spreading these 2 blocks into 10 pieces.
Partition.
10 partitions.
Okay, sir.
Understand? During runtime, remember, physical storage contains only 2 blocks only. But in the RAM of the nodes, in the RAM of the nodes, in the in-memory, all of you mute please. In the in-memory, we are spreading these 2 blocks into 10 partitions.
Okay, sir.
Now, if process started, number of parallel process is 10. Still you have more big data, more big volume, you have 10 blocks. Suppose you want to decide like each block into 10 pieces, then make it 10 into 10, 100 partitions. Now your data will be spread across 100 nodes. Even though physical data available in 10 machines, but in the in-memory, you are spreading that into 100 machines. Understood, all of you?
Yes, sir.
So
Yes,
that
sir.
4 speed. This is exactly similar way you are going to home now after completion of the class. The road is very empty. You are traveling by the bike. Now what you do? You are riding the bike. The road is very empty. What you are doing? You are
Yes, speeding.
accelerating, right? You are increasing the speed, right?
Yeah.
Yes.
Suppose if road is tightened with traffic, then you are slowing down, right?
Yes.
That way, by increasing number of partitions, by decreasing number of partitions, by increasing or decreasing number of partitions, you can control number of parallel processes. Understand? This is
Yes, sir.
called massive parallel process. Okay, let's talk about the Hadoop. In Hadoop, in the very beginning, what is the execution model? In Hadoop, in the beginning, what is the execution model? MapReduce.
We are dividing in.
MapReduce.
Yes.
What is the blind rule of the MapReduce? If number of blocks are 10, max number of parallel process, 10 only. Understand?
Yes, sir.
If I have 10 blocks, 10 parallel process, and I cannot go beyond that. Even though remaining nodes are free, I cannot increase my speed. But in Spark, you have a control, you have a provision to control number of partitions. You can increase the count, you can decrease the count. Okay. Suppose a cluster is already tightened with other jobs, sir. Then what you do? Cluster is fully tightened with other jobs. In this time, what you do? You can reduce number of partitions, right?
Yes.
Yes.
If cluster is empty, a lot remaining nodes are free. You want to engage them into the participation of the work. Then you will be increasing number of partitions. On that way, you can slow down, you can increase the speed. So that feature is with MPP, Massive Parallel Process. All of you clear?
Yes, sir.
Yes.
Sir, can the partition size be greater than the block size? Will it be?
So actually this block is a word related with Hadoop. In Hadoop, what is the storage? Whenever we call it as a block means this is related with
Hadoop.
Hadoop.
HDFS.
HDFS.
Whenever you call something as partition, what is this?
Spark.
H. D.
In-memory
In-memory
data
computing.
unit. In-memory data unit. This is about what? Spark. Understand? Suppose previously, easy calculation. Let's say block size 100. 100 MB. Think that you have 10 blocks. Number of parallel process
10.
10.
in Hadoop.
10.
In Hadoop with MapReduce. I mean old model. 10 only. Now same story I am talking here. Block size 100 MB still. And I have 10 blocks. Total data I am dividing into number of partitions.
10.
100. At the time of creating RDD only, I am setting that partitions as 100. Now what happens? This 10 blocks data
Will be
is
divided
divided
into 100 partitions.
total 100 partitions. Total now max number of parallel process now
100.
100, not 10. Even though 10 blocks, I have 100 partitions here, so that 100 parallel process. That too with in-memory computing style. In-memory
Sir,
computing.
when you say clusters means worker nodes, right, sir?
Cluster means one master, remaining all
Workers.
workers.
Slave.
Maybe 100 workers or maybe 1,000 workers, maybe 10,000 workers. Is there any limit for the Spark?
No.
No, sir.
For Hadoop, there is no limit means for Spark also there is no limit. Got it?
Sir,
Sir, so
here
these
block.
clusters are also present in partitions, sir. Clusters are also, worker nodes are also present in partitions, sir.
Reverse the statement. Worker
Parti-
node won't present in the partition. Partitions are presented in RAM of worker nodes.
Okay, sir.
Understood?
Yes, sir.
Partition means data piece. Got it?
Yes, sir.
Suppose I have 1,000 records, 100 partitions. You have 1,000 records, 100 partitions. Each partition contain how many records now? 10 records only. Understood?
Yes, sir.
On that way, those 10 records will be stored in RAM of one worker node. Second partition will be loaded into RAM of second worker node. Third partition to third, like that. On that
Okay,
way,
sir.
these partitions are runtime distributed across all the nodes. Got it? Finally, if it in Hadoop processes what? Hadoop processes what?
Parallel.
Processes what?
Blocks.
Blocks. Okay, come on, reverse it. Spark processes what?
Partition.
Yes. Spark processes the content which is available in the in-memory. The data unit in the in-memory that is called partitions. Just a key point, remember. Whenever you say something as a block, that will be processed by Hadoop MapReduce. When you say Spark, the Spark is going to process
Partition.
partition. Where is the location of these partitions? Where is the location of the
Worker
partitions?
RAM.
RAM, because in memory computing. Where is the location of the block?
No.
Where is the location of the block?
Nodes.
Hmm?
Disk.
Nodes.
Disk of worker nodes. Here RAM of worker nodes. All of you clear?
Yes, sir.
Is there any limitation for the like size limit for the partition?
Yes, definitely. Definitely. Suppose 1000 records. Just assume 1000 records. Data volume is no limitation. Okay. There are 1000 records. Can I go more than 1000 partitions?
No.
Suppose, okay, question step by step. Question number 1. I have 100 partitions. Number of records
10
in
records.
each partition.
10 records.
10.
10.
Okay. I'm going with 200 partitions. Number of records?
20.
Really?
5.
5. I'm going with 1000 partitions.
1 record.
Number of records in each partition? 1 record. Understand? If I go with 1002 partitions, is it possible? Is it
No.
possible?
No.
Yes.
No.
It's possible, but
No.
it
1020.
makes like 1002 partitions, but data adjusted into only
1000.
1000
Thousands.
partitions.
1000.
Remaining partitions are empty. Because of empty, it will deallocate.
Oh.
First,
So
initially
1000.
allocate, but no record found for them. That's why it will deallocate, it will remove. Unnecessary garbage, right?
Yes.
That's why it will remove. Got it. That means once a process got started, how many will be there? How many partitions will be there into the system means the max number of the records. Got it?
Okay. When the cluster is busy with the jobs, can we have only one partition? Or like
You can. Suppose if you set only one partition, how many parallel process now?
one parallel.
Only one part. There is no parallel process. Got it?
One process.
You can. So already I told you, traffic is very high. You are reducing number of partitions. Traffic is very free. You are increasing the speed. Similar to your bike riding. Understood? Okay.
Yes.
In our next session, what we target is, okay, before that, suppose if it is operating system, what is the data object? In any operating system, Windows, Linux, you take any operating system, or Mac OS, what is data object in the operating system? What is data object? If it is okay, before that, you will get a clue. If it is database, what is your data object?
Data.
Tables.
Tables, right?
Yes.
If it is operating system, what is the data object?
Files.
Oh, files, correct?
Of files.
Understood. Same thing. If the thing is Spark, what is the data object?
Partition.
Partition.
Partitions.
Koncham. I told you one name.
RDD.
RDD. Understand?
RDD.
So what I wanted to say is, in Spark, data objects are called RDDs. What is the full form of it? Already told you.
Resilient.
Rational.
Resilient.
Acha.
Remember, two things you
Distributed.
can guess.
Distributed.
Disk data.
Data set.
Data sets.
Oh, data set.
Distributed data set. Resilient, distributed data
Data
sets.
set.
Okay, why I said resilient?
Not sure.
If you are using the word resilient means there is a special importance. Come back to our beginning Hadoop introduction session. I used that word. Is our class resilient? Is our class resilient? Suppose Srinivas did not attend today. Class will happen or not?
We have to.
Happen definitely. Vidhi did not attend. Class will happen.
Yes.
Ram Shankar did not attend.
Class will happen.
Class will happen. All students did not attend.
Class will
Class
Class
will
will
happen.
Not happen. Bharat Sriram did not attend.
Not happen.
not happen.
That means our class is not resilient. Resilient means whether you come or not, it doesn't matter. Whether I come or not, doesn't matter. Class should happen.
Okay.
All of you understood the word importance of the resilience.
Yes.
Okay. So such kind of thing will be provided to your data. This thing is talking about data.
Resilient distributed
So
data
technically this RDD is a logical name which is collection of
set. Data set.
Partition.
Partitions.
what?
Partitions.
Understand? Again, one more statement I am adding. These partitions runtime distributed into, where is the location?
RAM.
RAM.
Rams of what?
Rams of
Nodes. Partitions.
Workers.
Worker nodes. Okay. Then one more statement I am adding. Treat this as statement number 1, statement number 2. These partitions runtime distributed into RAMs of worker nodes. Then finally, what to say? All these partitions will be executed parallel. All these
Partitions.
will be executed parallel. This is statement number 3. This entire thing is about one thing, RDD simply. Look at the first point again, is a logical name. In fact, physically there is no RDD object. For all the collection of if I have 10 partitions, for all the group of those 10 partitions, I am putting a name. The name is RDD. It's a logical name, which is collection of
partitions.
Second, these partitions runtime distributed into RAMs. Runtime
RAMs
is when I
of-
submit a process, when I submit process job. These partitions are distributed into RAMs of worker nodes. Then all these worker nodes will be processed parallel. That too with in-memory computing style. Understand? So this is a small word about RDD. More deeperly, we will discuss in tomorrow class about these RDDs.
Yes.
Yes, already this is with you, I think. Already all documents are in this. Yes. Can you recommend me topic?
In-memory computing.
In-memory computing.
Spark features. In-memory computing.
Disk-based computing.
MPP.
Massive.
Then
MPP.
Massive parallel
Parallel.
process.
Process. Then
SAP HANA.
Spark in memory. What is the difference? What is the difference between SAP HANA and Spark in memory?
Partition.
Spark HANA is not distributed. Spark in memory is
Distributed.
Non-parallel.
Small intro. RDD. What is RDD? Full form, please.
Resilient
Resilient.
Resilient
data.
Distributed
Dataset.
data.
Okay. So tomorrow completely we discuss about RDDs. Okay. So how exactly it works, we will get to know. So meanwhile, just prepare our own notes by seeing this document. Then you can understand more about tomorrow class. Okay, sir, all of you. See you there tomorrow. Thank you.
Thank you, sir.
Thank you, sir.